Okay, thanks for joining us. Welcome back to Ask an Engineer. My name is Andrew Garchik. I'm an application engineer for DesignPoint. I'm joined by my colleague, Brelan Blake.
How you doing, everyone?
Hey, Brelan, nice to see you today.
You
He
too.
is also an application engineer for DesignPoint, and
Yes.
I would say SolidWorks expert as well.
Yes. Thank you. Yes.
So today, I want to cover a topic that I get a lot of questions about. So in 3D printing, when you're 3D printing FDM style, which is what we do a lot,
Sure.
if you have an overhang, the printer cannot print over air. So you have to have some support material to hold up that piece of the part. But what a lot of folks like to do is do clever things to remove the support materials. So one thing that we've done occasionally is we've created like a teardrop or a diamond-shaped channel through a part because it can print at an angle over air, just not when it's too much of an overhang. So basically what I was hoping you could do is you could just kind of on a very high level, just walk us through how you would create an internal channel that has like a teardrop geometry to it for all the folks who are trying to come up with clever ways to get rid of support material in the part.
Sure. Okay. So, Andrew, if I'm understanding you correctly, whenever you have a square or a hard 90-degree angle, the printer will have a little bit of issues if it's on the Z-axis printing just in midair, of course, right? So you're talking about creating like a 45 or teardrop to alleviate that. Is that right?
Absolutely, yeah. Because once you get to a certain angle, then it actually can just print over air. But you have to have usually a 45-degree angle. That's what you're looking. Yeah.
Okay, great. Yeah, let's take a look. Let's jump into the model and see what we could do.
Awesome. Let's take a look.
Okay, Andrew, so we have a part pulled up here for just a quick demonstration of what you were talking about. So we just have a basic SOLIDWORKS part up on our screen, and we created a sketch here. And this sketch here from this position is just going to show sort of a teardrop shape here, just like Andrew was saying. So we place this sketch right on our top surface. If this was a squared off cut and a round circular bottom, we would have an issue with the top square 90-degree. We would have some issues with that printing, depending on what axis that this part is actually turned on the printing bed. So to alleviate that, we have a 45-degree angle here within our sketch. And we are just going to take that sketch and we are going to create a cut sweep here. And just with fast forwarding through here, make sure that we don't have any delay issues. Now you can see we have just a cut extrude here, which would go down through the top and out through the edge. If we go ahead and do a slice right through our part here, take a look and see what that looks like.
Wow, that's cool.
So hopefully this will alleviate some of our printing issues here with the hard angles. So by decreasing the two angles on the top here, that would allow this to print a little bit better and not have any issues with our print.
That's really neat, Brelan. How do you create that conformal pathway?
Oh, sure.
I think you already explained it, but just
right. So I created a sketch on this the top surface of this part, and by using a 3D sketch to create a cut contour here, I use a cut sweep feature, which is going to give us that shape through our cut part. So our sketch here is placed on the top of our plane, and then we have a 3D sketch that's going to control the center line and sweeping action of that cut. It's going to go right through the sidewall. So this is mimicking maybe something that you would see in a forming tool, where maybe a customer or something would have something pour through here and out through this cavity to the side.
Yeah, this reminds me of an application that I did recently, which was an injection mold. So an injection mold, the holy grail and how folks are trying to use 3D printing to make that process way more efficient is by creating conformal cooling channels. So basically, you would run your channel right up to your mold cavity, whereas with regular you know, machining, you can only do basically like a straight line. You know, you could like drill through your part, but using conformal cooling channels in 3D printing, you can get your channels much closer to the mold cavity, thereby allowing those cooling channels to disperse heat way more efficiently, which reduces the cycle time, and the faster they can do their cycle, you know, the much less expensive they can make their parts. But that's neat what you're showing me, this cut sweep tool. So basically, you need two sketches, right? You need a sketch of
Yes.
like the actual geometry, right? That, like
Right,
the actual
right.
teardrop shape, and then you need
Yep.
another sketch which actually just tells it where to go.
Sure, that's exactly right. So the first sketch will consist of our profile cut of what our cut is going to look like, and then our 3D sketch is actually going to incorporate the cut and the direction it's going. So my 3D sketch here, I have it placed in the middle of my sketch profile, and then I swept that out just past the surface out through the other wall inside of the part.
What if I decide that, you know, once I see that channel through there, I want to, you know, iterate it a little, you know, I want to give it a little, maybe I want to move it up a little or move it down a little. Can you do that easily?
Yeah, sure you can. It's all controlled by our 3D sketch here. So with our 3D sketch, we're going to just change some geometry features here with where we're actually going to show. We're actually going to show this cut being, and we can increase that. And I have the 3D sketch actually coming through the wall here, or we could place a mate on the face of this, the inside wall of this part. And by doing that, controlling that, we're going to increase or decrease that that profile, which way it's going on the inside of our part cavity.
Gotcha. So basically, you just alter the sketches, and then you hit save, and away you go. And then you've got all your changes.
Exactly. Yeah, that 3D sketch is going to control the sweep cut of our profile sketch.
That's great. Yeah, and you know, I'm sure you could do many different types of geometries of holes, right? Like we're looking at a teardrop shape here, but
Sure.
certainly you could do a diamond shape, or you could do, you know, even just like you could do half of that teardrop if you want to just come up at an angle and just
Sure.
have an angled top to a cavity as well. So there's probably a lot of different ways to do this, but
Sure.
no, this is neat. This is definitely easier than I thought it was going to be. So I think I'll wind up using this quite a bit in the future moving forward. Thank you for walking me through this.
Absolutely, it's a pleasure. Thank you for demonstrating a part for us.
Absolutely. All right. Thanks much.
All right, thank you.